Okay, here we go. Sorry for the delay. I'm going to drop the link on everybody of the of the live stream, which will also be the link. There we go. It will also be the link for the archival later on. So if anybody wants to join, hang on a second. Okay, I'm dropping this link over on Teams and hang on a second. All right, just drop it on Teams. I will drop it on Discord. I don't see anybody live trying to watch via Discord and or Teams. So I'm just going to not worry about the interactivity, although I'd be happy to handle any chat on either Teams or on Discord. And then in the meantime, what you can see is I've got lecture 1 coming up. Now, so appreciate your patience with both the late start and just being remote again. Anyway, I went to the doctor this morning, have an ear infection. What's, that's like when you're 8, you're supposed to get ear infections, or when you're a baby or something. I have no idea. But anyway, so it's just kind of an energy sap, and I also don't, just out of an abundance of caution, don't want to be walking around campus. So appreciate everybody's patience with that. I hope the exam went well. I'm sure it was a blast. I haven't done any grading on it. I'll see if I can maybe look at that a little bit tonight. On Wednesday, what we're going to do is do a little bit of a breakdown of the exam, and then get on to a few other things. What we are trying to do this week is we are trying to get through 11, 12, 13, and 14. And what I'm going to do today is 11 and 12. I think you're going to find it not, the lectures themselves, getting through the lectures is not that tough. The material itself is stuff that you're just going to have to dive into on your own. There's no way to like lecture you. It's like lecturing you on how to use a wood lathe. You can watch all the videos, but ultimately you've got to grab your chisel and get on the lathe. And that's what you have to do with this kind of stuff. So what I'm trying to do is give you sort of an orientation to what you're doing. And then in the assignment itself, there's a bunch of information that relates and points you back at the slides for reference material. So it's just a little bit, it's a little different. So, okay, let me see. Where are we at here? Okay. All right. So let me see. Katerina had dropped a comment in Teams, so hopefully we're all good, right, with the ability to see that, I hope. And if not, you'll be able to look at it there in a little bit as soon as I got it posted. Okay, so let's do this thing. The lecture 11 is about client socket calls, and lecture 12 is about server. So essentially, you're going to be digging deep and getting a little bit more into client server computing, really. And you're going to be doing this via sockets. Okay. So these are things we've already talked about in terms of the spec, but this is where you get to do it in practice. So this one, let me see, lecture 11 has 23 slides in it, but there's a lot of it that's going to just be detail that will be primarily a reference for you, okay, for later on when you actually dive into writing the code. um, I will say there's a few things about the slides. Oh, and I think that slides for lecture 12 are much shorter than this even. Uh, this is a very confusing slide in my opinion, but what it's what it's trying to suggest is that in between every layer there has to be some kind of standardization in terms of interface. Otherwise, you can't you can't write generic code. Everybody wouldn't be able to write to it. You know what I mean? And so there have to be these standard APIs. This is one standard application programming interface, like the sockets API. Sockets isn't the only one, and there are different brands of sockets. So, those all kind of come into play. And then interfaces. So the app developer has to be able to write to a standard API like Winsock or something. And then in the operating system, you're writing TCP and IP, and all of that can be that non-standard interface just means that can all be kind of custom, cobbled together, whatever. But when the programmer is trying to write to it, it has to be standard. And then when the protocol stack sits on the hardware, that has to be standardized. That's all that's really trying to say. And so what we're going to be trying to look at, and you guys know I have my external monitor this way. So when I'm looking this way, it's just because I'm looking at a larger view of what you see right here. Um, but so this top layer is network and web app programs. And there's a bunch of different things. For example, there's socket classes that work with languages like C#, C++, Java, Python, Ruby, Perl, et cetera, et cetera. And then there's web services like REST and SOAP that sit on top of remote procedure calls and remote method invocation, RMI. And all of those sit on top of a sockets API, usually Berkeley or Winsock, as sort of the major brands of sockets API. What we're going to be doing, and the reason it's highlighted in yellow, is you can write directly to that sockets API, and usually you do that in C. And I think that after class there was somebody last time that was like, do we really have to do that in C? And the answer is yes, you do. Um, I honestly don't know how much C you guys have had. If this is your first, is this your first exposure? I hope not. But somewhere along the line, it's a tool that needs to be in your toolbox. But anyway, that's what we're going to be doing is writing this direct socket stuff. Now, this is the part where we always have the big ugly slide. I'm going to hit you with just a few key things that I think might be valuable. Okay, so the socket is an abstraction. It has to be implemented in a concrete way, but it is, an abstraction. Um, you know what I mean? It's a conceptual idea, and the way and so this last part, it represents the point where a local application or process attaches to the network. And it really is just a way of saying, I'm an endpoint. You remember when we talked about IP and TCP, and we talked about MAC addresses, we talked about IP addresses. And, these are like endpoints the MAC address is an endpoint for the hardware to talk to the other hardware, and the IP address is a way, right, of the machine to identify itself as an endpoint for another machine. And then on top of that, we had ports, right? Well, this is yet another abstraction on top of all of that to sort of say, I'll just open a certain socket, and that socket will be an endpoint on the other side of the connection. It allows me to simplify the whole thing, so that I don't have to remember. It's a method of managing abstraction. So I don't have to remember everything going on, at every level and carry all that with me at all times. The protocol stack architecture is all about managing abstraction. Um, so key ideas, think of it as a handle. I don't know if that's particularly helpful, but several sockets can share one network interface, kind of like ports. One app can use multiple sockets. Servers do this all the time. They open a bunch of sockets. It's not the same as a connection, okay? You've got to have sockets on both ends before you can make that connection. A socket is not a port in the TCP sense, but sockets and ports are related. We'll try to give you a little bit of a sense how. And again, some of this is going to be in the doing, that it'll be a little more clear. In case you need to differentiate, if you're using Unix, Linux, Mac OS 10, which is based on Unix, then you're using Berkeley sockets. And if you're using Windows, you're using Winsock. Okay. I believe the labs are all built for Windows. And I don't think I have a problem with you doing that on Unix, Linux, Mac OS. Although I may, the materials may give you a little less help. I can't remember. And we'll go in and we'll look at the assignment stuff. But so two different kinds of sockets in the TCP/IP environment. The stream socket gives you access to a TCP connection, and a datagram socket allows UDP datagrams to be sent and received. So the idea is that TCP gives you this endpoint for a stream of data. And then the metaphor is like reading and writing to a file, right? Reading from and writing to a file. And with UDP, it's more like, here's a packet, here's a datagram, do with it whatever you want. It's less of that kind of streams metaphor. So here's the idea. You've got, and again, this layering that I've just been talking about, network, the IP stuff, TCP and UDP sitting on top. A stream socket, app 1 is talking to a stream socket via TCP. Application 2 is talking a datagram socket to UDP. That's the abstraction, right? That's the layer, the stack layer. Okay. Yeah, there we go. All right. Ways to get to this Winsock API. Now we're going to do it in C, okay? But just to illustrate the idea that in C#, this is the namespace, system.net.sockets. In Java, the java.net class. In Python, you've got module socket and socket server. C++, there's no standard library, at least as of this slide, and I don't have personal knowledge of that. On Windows, you do pound include using C, okay? Pound include winsock2.h and ws2 tcp/ip.h. Those are just pound include, then that causes the libraries to be linked in. And then on this star nix, that's just a fancy way of saying Unix, Linux, any other nix, and OS 10, which is based on Unix. You've got pound include socket.h, which is the traditional Unix sort of approach. And then that's something, again, that's just a C thing. It's the way you include at the top. This is what we're going to be doing. And Most of the other languages are built to look and feel as similar as possible, given the metaphor. And what we're going to do is look at the direct Winsock function calls. Okay, so we're in Windows and we're going to use these function calls. Let me see. And in case anyone's interested, this list down here on Stack Overflow will give you, more of these network libraries. In case it's interesting to you, the difference between Berkeley sockets and Winsock. Um, in Berkeley sockets in Unix, the socket functions are built into the OS kernel, which means that the API is giving you access down into the operating system. And for Windows, the sockets are contained in a DLL. Okay. So for these versions of Windows, that's the DLL, ws2_32.dll. And anyway, the dependency on that has to be configured in Visual Studio. What else to say about this? In Winsock, you got to load the DLL before any socket functions are called. And then you have to notify the DLL when your program terminates so that it can release socket resources. This ain't Java, my friends. Okay, so here's what we do. We're going to start with this and then we're going to end with this. This is basically to deal with both client and server. These are the things that happen. There's a Winsock function that gets called. And this, I've been fair game to badmouth the slides, and some of the slides, certainly merit some badmouthing. This is a good slide. I think this is a really good slide. Just so you know, we're on the same page here. When you've got a client and a server, they're each doing things independently, and then there comes a point where the client starts something. Okay, and then they start moving back and forth, and then they tear down the connection, right, where the client wants something from the server. So this is just identifying the various functions and who uses them. Okay, WSA startup, and these are again all Winsock. So that's the point of reference. If you want to go Unix, then you got to look at the analogy, the analogous versions. But they both have to do WSA startup, which just initializes the Winsock DLL. They each have to call this socket function, which returns a handle. You can call it whatever you want, but here it's called sock. But and then the details, I'm not gonna handhold you through all the details. I'm gonna try to give you enough guidance to get you moving, and then hit the documentation, hit some of the details in the slides that I'm only gonna gloss over. Okay, but when you do, anyway, there's the sock call. They each then have a socket. The bind is done by the server, which, and I'm honestly a little thin on the bind. And I think it has to do with just some local detail on the server side. That's my understanding, because there hasn't been any request to connect or anything yet at that point. So it has to do with binding that socket to some other thing down below. Then there's a listen, which is simply waiting for connections on that socket. The accept is when I get a connection request received. Now I would probably flip the order here, but if I do get a connection request, then it saves this information, the client information. So this is the information about the other endpoint. When I opened the first socket, that was my endpoint. And then when I get a connection request, it comes with the information from the other endpoint. I got to save that handle away. And that's here as CL_sock. Clients send the connect requests, okay? At that point, it's simply a matter of sending data, which transmits either direction, right? Both the client and the server are going to use this. Receive, which is to read the receive buffer, close the socket, and clean up, shut down the DLL. This is not crazy complex in my view. And the key is everything we're about to dive into. Hang on, I just want to see something. All right. The key that, and this is really, really important. I can talk and talk and talk and talk and talk. Actually, I can't because I'm just too tired. Can you see how tired I am? I'm not feeling well. But I can talk for as long as I could talk, and it's not going to mean anything until you do it. It's like this is like Hello World, okay? You just have to do it. You have to. So everything I'm about to say going forward is going to be a little hand wavy because I haven't I've done all of this stuff in the past. I haven't done it recently. And so, but it's okay. I don't need to like diaper change you and bottle feed you to like, okay, now type this, now type this. This is, this part of this maturing. Get the thing set up, get it working, and take your shot. These are the header files for Winsock. Okay, again, if you're going to do Berkeley sockets, then this is what you're going to need. But for Winsock, these are the two, and this is how you do it in C. Pound include in the brackets, and then you've got to get your Visual Studio environment set up. And the first thing that I would do is, um, do something like write Hello World in Visual Studio. Just make sure you can build, that you can run anything. Okay. Um, okay. Let me see. Next part. This is the prototype. Now, this is mostly, I'm not going to walk you through all of this. I'm going to leave the bulk of this as documentation to help you. Okay. Um, there's some history as to why that says Pascal. Don't worry about it. It's a far pointer. That's the function prototype. These are the parameters that you pass in. So here's a sample, WSA startup, and you can just try it, just do it. Okay. What I would seriously do is I would include those, and then make a main, and just do hello world. Um, and if you don't know already how to do that, just look it up online. Just a main that doesn't do anything. I think later on there's actually some code coming up. Where is it? Well, somewhere here there was I thought, sorry for the convulsion inducing. Anyway, do a main and just do hello world. Get that working. You've got to get that working first. Then you know that the environment works. Um, okay, so that's your startup code. And then this is the documentation. I'm not going to walk you through it in great detail. What we will be able to do also, because we're starting late, I think this is set to be due, I want to say Wednesday or something, but we need to push it back to be fair to everybody, just because we're talking about it later. We're catching up with the class, but we are talking about this late. Um, and then just read it. Like if you're like, what's make word? You can either freeze right there, or you could read the rest of the slide where it tells you that it's a macro defined in the Winsock that puts the major version number where you need it, so that it does what you need it to do. All right. Then this is the prototype for socket. Now I'm going to go through this pretty quickly because when I get to, and then when I get to 12 later on, if we can get to it, I might see if I can get to, um, man, there's a little bit in 13 that might be helpful, but in lecture 13. So anyway, this is the socket call that we talked about, and all the description is right here, how you use it, what you do. What we can maybe do is maybe on Wednesday we can talk a little bit more and talk about some specific questions, try to help each other with that. These are the socket address info structures. And again, I'm not going to walk through all of this because none of this is going to mean anything until you start playing with it. Then the questions will have meaning. Okay. Again, the host to network short, and what is that one? Function prototype for presentation network. Again, just give these a read, and this one, man, have you talked? I don't know if in Networks One, if you talked about big endian and little endian. That's endian, not Indian. I don't know if you talked about it, uh, but it has to do with the way you read a data stream. You'll be able to know if you got it right by running some tests to see what it is that's coming through. And if it comes in all scrambled, then you didn't, then you're not doing it right. Essentially, if I've got bytes that look like this, they wind up being essentially sort of like each sort of flipped and then reversed order. In essence, it sort of like takes the thing and flips the order. Um, and that's what this is trying to show you, but it does it with a byte at a time. Play with this, and I'm not sure how much of a trouble. My problem is having not gone through all of this stuff in the past. I don't know. I don't have the advantage of knowing what is going to trip you up and what's not. You know, like what to forewarn you about. But we can come back from getting the port number correct. Again, it looks really ugly as sin, and I'm not going to go all the way through it. I just want you to be aware that this is here and maybe just demystify it just a little bit. Again, here's sample code that you can look at to see what the different functions are. Here's connection establishment. And then if you go look, you can look on the sniffer and actually see when you've successfully sent these messages. That's one of the reasons we had you, do Wireshark and learn how to see the packets that you're sending so that you can see them as they're going out. Okay. Then there's send, receive, close socket, and then again you can see the response when the closed socket's called, and then WSA cleanup, which shuts everything down. And that basically is walking through all of the things that the client has to do. Okay, that's what that's all about. Now those slides are on Canvas. You already know that. Now what I'm going to do is real quickly walk through. I'm going to real quickly walk through what the server does. Which is the 12 side. And then I'm going to pull up the assignment, okay? So that you at least know that the problem is it's one of those sort of cyclic relationships where the material doesn't make any sense until you see the assignment. The assignment doesn't make any sense without some view of the material. So I'm trying to kind of bootstrap that a little bit. Okay. Let me see. So here's just a little bit of extra help on some C syntax to kind of guide you just a little bit. Let me scoochy my face just a little bit more. Okay. I don't want to block. When we're talking about syntax, I don't want to be blocking slides. Pound define and pound include are compiler directives. They tell the compiler a little bit about how to behave, what to do. In particular, to take all that code and just to include it right here as if you had typed it all. And pound define similarly, where you can define certain things. So one thing to do is to exercise good skill, good coding style. So if you have a buffer size, define it here as buff size. Later on, if you want to change the buffer size, you just change it here once, and then everywhere that you used it, it gets changed. If the opposite of that is what we sometimes call magic numbers, they're almost always a really bad idea, especially when they relate to a generic concept. Okay, so magic numbers relating to um, a buffer that could be 50 or 100 or 200 or 1,000, and coding that number in, then you've got to try to look through your code if you ever want to change it, looking for the occurrence of the number 100. You're doomed. Change buff size. You can always scroll through to look for buff size if you need to, but mostly you just change it and you're going to be okay if you do it right. This is the way we declare an external function. And now this is where we get to main, okay? And we're going to talk about command line arguments, but this is one of those really interesting things. Does the next slide? Yeah, let me go. Well, let me just say this. Frankly, the colors and the font are making my brain explode. But this is the way you set up the main function in a C program. And every C program has to have a main. Main is the thing that takes, you can have all the functions, all the other stuff, kind of like methods, but we call them functions. In C, you can have all that stuff. But when the program runs and you say go, this is what runs, this function called main. And when you're on a command line, like you're in Unix or you're in a DOS box in Windows or any command line, you can pass through. You know how you say, I don't know, what are some tools you've used? grep, and then there's like a file name and there's other stuff, right? Well, all the things that you type is what we're going to talk about, show up in argc and argv. This is a really, really important idea. You should get it in operating systems, but you need to understand it here. Then you can have your local variables that are declared, or the global variables really to main here. And then there's some procedural code. But let me look over here again. I apologize for the horrible, you know, just the way the font lines up. Just it's making my eyes bug out. So this is what was typed on the command line: ws echo client v6.exe. And then this is just what they typed. Stuff, all this is one argument. And what it's meant to try to show you is that the argc is the number of arguments or parameters. Sorry, not just parameters, it's arguments. So the name of the file is the first one. That's 0, 1, 2, 3. So a total of 4. So down here, argc equals 4 in the sample command line above. So it's an integer and it contains the number of arguments. This chart we'll sometimes call a char star, character star. It is an array of strings, okay, or of pointers to strings. And what you can actually do to dump that information is set up a for loop that just basically just prints out let me see, does that go on? No. But I was hoping, anyway, I would recommend you play around with this. Type different things on the command line, and then inside, just look and see what argc is. Print it, print argc. And then set up a for loop from 0 to argc minus 1 and print out as a string argv sub I. And in this case, because of the way that thing works, they're simply saying the server IP address is the first part. In other words, it knows what it's trying. In this case, it knows what the parameters were supposed to be. And this is just an echo client, like we talked about. Here's a server port and a phrase. So that's the address, the server port, and the phrase. And you can basically just pull those out. See hard coding argv sub 1, sub 2, sub 3. Okay. And you can kind of ignore argv sub 0 because that's just the name of the file in the first place. Okay. You have to play with this. I cannot, there's no way for me to spoon feed this unless you're the one typing it, experimenting with it, playing with it, trying it different ways, you know. Okay, now this gets us to programming assignment 1, which I'm going to open up in the in Canvas. And by the way, I guess there's a total of 18 slides here. Just FYI. So the assignment is to code up a Winsock client command line application. So it's got to be a command line application. It's got to be in C, and it just sends a message to a server. Doesn't matter what the message is. And I don't think it matters in the assignment. And so here's the deal. The server then just echoes the message back for display by the client. So you send a message to the server receives your message, sends it back to you, and then you display kind of like what you sent and then what you got back should be the same thing. That's why it's an echo. The assignment provides you with the server, a functioning server that you can't see the code for, just a functioning server. So you can test your client. Then when your client is working, you're going to build the server. You'll kind of bootstrap it. Does that make sense? You'll start off with a working server. Okay. Go to this folder, Programming Assignments, Program 1. It's the file folder, okay, in Canvas. Read this PDF to get yourself going in Visual Studio. And if you don't have a Windows machine, use one in the network lab. Let me see. The program1.pdf is the program spec. There's a, now I'm going to pull this up for you. The program1 template.c, it's very much fill in the blank. It's nothing but comments. Initialize the one thing. Do this, do that, but it's just comments. You've got to fill in the code, okay? Use display fatal error or display, fatal error. There's the server, the WS Echo Server 6, e6.exe. Use this loopback address so you can run it on the same Windows machine. And C syntax and debugging might be a bit of a struggle, so get after it. Okay, don't piddle around waiting to get started on that. I haven't looked at this very carefully at all, but this is the extra credit. I would get the first thing done and then come back for this. Okay. If you enhance your client so that it can accept a dotted decimal IPv4 address and communicate with an IPv4 server. And then there's a server v4 that you can test with. Okay, fair enough. So this is that same thing. These are the ones that we're now doing as we're building the server side. okay? And once again, here's some sample code. The key is there's always an interesting danger when you're provided sample code. If you think that you can just like type all this code in and then try to somehow punch it until it works, you're doomed. You have to look at each one as a tool. You've got to understand the whole structure, how it all fits together, how it all works, what that main assignment thing is trying to tell you. Then use this as resource material. Okay, there's the bind, there's the listen, there's the accept. And this is an attempt, it's really butt ugly, but it's an attempt to articulate the full sequence. The server starts up, you can do this yourself, makes a socket call, bind, listen, and then accept. Over on this side, there's a WSA startup, socket call, then there's a connect with the accept, which finally returns. The accept opens up, it gets ready. But again, walk through these. And the other thing I would strongly recommend is that you take these, you take this really slowly. You do one thing. You got to listen to me on this one. You got to listen to me. Anybody who comes and says, I've got it mostly working and they've got code everywhere and they don't know where it breaks has done it wrong. Okay. You do one thing and then to the extent possible, you test it so that you know that the one thing actually works. Now, the best way to do that is to build in C, you use printf. Printf is just a print statement. And what you're going to do is say printf, got right here, got to main, you know, and then um, when you make the initialization and it returns, you're going to say printf, initialization. Here are the values. Dump the value. Show that you know every step of the way. You know what actually happened. Okay. And then this is, here's what we've been doing, but then there's just a little bit of other stuff. I'm going to hit this super quick and we can maybe revisit on Wednesday because do I really want to hit this? No, no. What I want to do right now actually is I want to go back over to Canvas. I'll have this dragged over there in just a second. Okay. This is a little bit ugly. Over here is programming assignments, program 1. Okay, these are the documents. This is where you got to go. Compiling a C Winsock program in Visual Studio, depending upon which version you've got. The C file we talked about, these are the DLL files. Okay. And right here, and there's those echo servers that you can just run. This is TCP Spy, which is a sniffer. This is a style guide. Okay, it's only 4 pages, but you need to look at this and you need to follow the style guide. There are reasons why the style needs to follow the style guide. And then here's the program where it walks through. So you've got to read this carefully. It's saying 3 to 5 hours. Your mileage may vary. Why do we do it in C? Here's the rubric. Here's how do you compile your thing with Visual Studio. The stuff that's been provided. Okay, so you've got to walk through this thing. Walk through that carefully. And then this is what's going to save your bacon right here. I'd like to thank Dave for this. First of all, double forward slashes in C are comments. The whole rest of the line is a comment, okay? So, I mean, that should already be second nature, right? C++ does that, right? Anyway, so these are the required header files, and it just shows you how to include them. There's a little bit of wraparound, which is unfortunate, but I think that when you open this in a text editor, it's not going to wrap around like that. But notice that it just kind of goes, declare your functions. Here comes main. Declare all the variables. Retrieve the command line arguments. Initialize the Winsock DLL. Create a whatever. If you do an extra credit, here's where you're going to deal with it. You know, just it's going to walk you through in the comments, and you're going to stick your code right after each comment. Okay, that's it. Okay, so that's the assignment. That's where you're going with that thing. And so I think what I think I'm going to do, I mean, we do have a few minutes. And I'm actually not like fully prepared on this next part, but I think that if I can get through lecture 12, it will get to the end of it, and then I'll actually show you real quick where we're going to be going. Let me see. Yeah, let me just finish the last slides. Let me just finish the very last slides from lecture 12. What this is trying to do is introduce you to the idea of RPCs and RMIs. Remote procedure call, remote method invocation. Those basically mean the same thing if you think about it, right? Back in the day, we didn't have methods. We called them procedures and functions. And the idea was to take a metaphor like I want to talk to, my client wants to talk to the server. Well, what if the server was just, you know, a set of functions like a library? And then I could just make a call like I would make a procedure call, just call the procedure. But what we're going to do now is we're going to basically have that same idea, except for the procedure that we're calling happens to be across the internet somewhere. That's the idea. That's the whole germ of the whole idea behind that. So these are the OSI layers, which you should have gotten those in Networks 1, but this is the Sun ONC Plus. Just kind of shows an example of our remote procedure call sitting on top of sockets, okay? And this is just trying to compare like a local procedure call with a remote procedure call. I mean, local procedure call, you got that. You understand the notion of how I make a call into, you know, some other local library or part of my same program. It doesn't matter. In a local call, the calling module actually executes that call. It executes the procedure call, and it's all local, really. This one, we have to load everything into a data packet. In this case, I transfer control to the procedure. In the case of the RPC, I basically block on I/O, and I transmit that packet to the server, and then the server unloads the parameters. Then on the server side, this next line, parameters get passed to the procedure residing on that server. I mean, essentially, all that's happening is, imagine you're making a call. Well, the procedure's not on your own machine. So what do you have to do? Take the call information, bundle it up, send it to the endpoint where they'll unbundle it, run it, rebundle the results, and send those back. And it just looks, you know, it just looks like a regular function call. And let me see. I'm trying to figure out which of these than I really want to deal with now. I'm going to pause right now, and part of the reason is um, let's pause right here on 15. I'll resume this on Wednesday. Hope I'm feeling better by then. But my urgent plea to everybody is to get started on this other thing. I'll push the deadline back a little bit, but get started now. Get started immediately. Okay. It's critical that we get started immediately on that. Um, okay, that's all. I think that's all I've got. Unless there's any comments. So Futuza, it's strictly C. I'll also put the question was, um, is it okay if we use C++ features in our program? And the answer is no. It needs to be strictly straight up C. Sorry. I don't know. Sorry, not sorry. C was the language. This is my bias maybe, but C was the single language that I was actually most fluent in in my professional coding career. And that's not why I'm saying this is what you have to do, but I am saying that this is what you have to do. I think it introduces a lot of other complications when we get to C if you try to include C++. Okay, any remaining questions before I truncate? If not, I'm going to shut it down. I know that a few of you are not feeling well. I hope you feel better. I hope I feel better. Let us all feel better together. Alrighty, I will see you on Wednesday, hopefully in person. Later.